So now we're on the bottom of page 6 and we're getting into factoring, and this is a really important, essential skill to have to be able to do a lot of the other problems in the rest of the course. And we're going to be talking about 3 main types of factoring. And the first one you need to know how to do in order to do the second type of factoring, and then you need to know how to do the second type of factoring in order to do the third type. So all of these, one just leads to another. So what factoring is breaking down an expression into factors, or reversing the multiplication process. So for example, you can factor a number, so say factor the number 12. Well, that can be factored as 4 times 3, or it could be factored as 2 times 2 times 3. There are several ways to factor the number 12, but the point is that it's being broken down into something times something. So anytime it asks you to factor, your end goal should be something times something, or something times something times something. It should just involve multiplication. So the first type of factoring is factoring out a greatest common factor. So this example is asking us to factor out the greatest common factor of the following expressions. So for part A, we have 2 terms, so this is a binomial, and when you want to factor out the greatest common factor, the first thing you do is look at the coefficients. So first is 5 and negative 35. And you think, well, what's the greatest factor that both of these have in common? What's the greatest number that both of these coefficients are divisible by? And 5 and negative 35 are both divisible by 5. I'm going to put that down. Then you move on to the variable part. This is c cubed d, and this part is c. So the most that the variables have in common, they both have a c in common, and that's it. So you write that out in front, and this is called our GCF. This is our greatest common factor. And then you put parentheses, and then you write down what I call are the leftover parts. So what we're doing is we're taking each term and dividing each term by 5c, and then writing that result in here. So 5c cubed d, we're dividing it by 5c. So 5 divided by 5 is 1. C cubed divided by c, we're left with a c squared, and then we'll still be left with a d as well. So we're basically taking 5c, kind of factoring out, pulling that out of this term, and we'd be left with c squared and d. And then we have a minus, so I'm going to write minus. And if we take 35c and divide it by 5c, 35 divided by 5 is 7, and c divided by c cancels out. And we're done. So all we're doing is turning this binomial into multiplication like we did here. So we turned this expression into something times something. And you can check your answer. It's a really good idea to check your answer whenever you can. And so to check our answer, we could just use the distributive property. We could distribute the 5c back to each of these 2 terms, and you will end up with this expression, and that's how you know you did it correctly. Okay, so that is our answer. We factored out the greatest common factor. So the greatest common factor stays out in front, and the leftover parts go in the parentheses. Let's do another one on the top of page 7. This time we have 3 terms that we want to ask, what do all 3 terms have in common? Well, first we look at the coefficients. We have 5, negative 1, and 3. those three numbers are not divisible by any other number besides 1, so nothing really to do there. And then we have the variables ab cubed, and ab squared c squared. Well, so for the variables, they all have an a in common, and they all have a b in common. So I'll write that out in front, then put parentheses, and then we just kind of write the parts that are left over. If we take out an AB out of the first term, we're left with a 5. If we take AB out of this second term, we have, first of all, we have a minus, so we got to write that down. If we take the A out, that's gone. If we take a B out, we're left with B squared. And then this last term, we'll be left with a number 3, so plus 3. We're taking this A out to the front, so that's gone. We're taking one of the b's out, so we'll still have a b left, and we'll be left with a c squared as well. And then close that off, and we're done there. And again, if you want, we can check it. You could distribute this ab back to all three of these terms, and you will get this expression, so you know that it's correct. Okay. Always want to check your work if possible. Okay, so that's the first type of factoring, called factoring out the GCF, the greatest common factor. Now let's move on to factoring by grouping. Now this technique applies to polynomials that have 4 terms. So anytime you see an expression with 4 terms that you want to factor, you should instantly think, okay, factor by grouping. This is the technique I need to use. So step 1, factor out the GCF, like we just did in the last 2 examples, if there is one. Step 2, you kind of just imagine the first 2 terms grouped together, hence why this technique is called factor by grouping, because you're kind of grouping the first 2 terms together as well as the second 2 terms together. And always be mindful of the signs of the monomials involved, meaning if they're positive or they're negative. Step 3, factor out the greatest common factor of the first pair of terms, and then factor out the greatest common factor of the second pair of terms. Step 4, now the parts that are left over should be the same. And you got to check that. You got to make sure that that's the case, and that will indicate whether you're on the right track or not. If they turn out to be the same, you are good to go, and if they turn out not quite the same, then you need to go back over your steps and double check them. And then you factor out these leftover parts. Alright, so I'll do an example to show all of these steps. So step 1, factor out the GCF if there is any. So we look at all 4 terms. Do all 4 terms have something in common? No, they don't have any factors in common for the coefficients, and they don't have any variables, all 4 of them in common. So step 1 is done. Step 2, imagine the first 2 terms kind of grouped together. Do not put parentheses around them. You're just imagining the first 2 grouped together, these 2, and the second 2 grouped together. Okay, done with step 2. Step 3, factor out the GCF of the first pair of terms. So for now we're only going to look at these 2 terms. What do these 2 have in common? They just have an A in common, so I'm going to write an A, parentheses. And if I take an A out of each of these, I'm left with a 3A plus a B squared. 3A plus B squared. And close it off. Now we're done with these 2. Now we're going to move to this pair, and ask what do these 2 have in common? Well, clearly they both have a minus in common, so we got to put a minus there. And they both have B in common. And that's it. So I'll write B, parentheses. And then we write what's left over. if we take a b out of each of these, we're left with minus 3a for this one. Oh, nope, not minus 3a. Sorry about that. We're left with a plus 3a because we took the minus out. We wrote minus here, so that's saying we're removing the minus from each one. So 3a, and then this one then becomes plus b squared. Plus b squared. Okay. And again, we can check our answer at this point. We're not done, but we can check if you distribute this a back, you'd get 3a squared plus ab squared, which is here. And then if you distribute this minus b to each of these two terms, you'd get minus 3ab minus b cubed, which is what we want here. So we're good. Now we're on step 4. It says the parts that are left over should be the same. So let's check that. This is what I call the leftover part, and also the same here. Are they the same? Yep, they're the exact same. 3a plus b squared and 3a plus b squared. So do not just write them the same because they're supposed to be the same. You should be checking after you've done your work and asking yourself, did they turn out to be the same? Okay, and they did. So moving on, it says factor out these leftover parts. So what that means is I'm looking at this as a whole, and I'm looking at this part as a whole. And if you look at these two whole parts, what do these two whole parts have in common now? Well, they both have a 3a plus b squared in common, so I can pull that 3a plus b squared out of each of them, and what are we left with? Well, if we take this out of this term, we're left with an a. If we take this out of this term, we're left with a minus b. And so what we're really doing when we're taking it out is we're dividing each term by this whole expression. But in any case, we're left with this. And we are done now. So we turned this whole expression into multiplication, and that's what factoring means. We turned this whole thing into something times something. And you could check it. You could FOIL it all back out, and you'd get this. Okay? Let's practice another one. So let's go through the 4 steps again. Step 1, factor out the GCF if there is any. Do we have a GCF? Let's look at all 4. I see that all 4 are divisible by the number 3. So I'm going to write a 3 out in front. And then I'm left with, if I divide each of these by a 3, I'm left with 2x squared plus 6x minus, this one divided by 3 is just minus x, and then minus 3. Okay. Now this 3, not going to do anything with it the rest of the problem. It's going to hang out in front. Okay. So I'm going to put a 3 there, not worrying about it. I'm going to focus on this part only now. And I'm going to do all the rest of the steps on this part of the expression. So, step 2, we're supposed to imagine these two grouped together and also imagine these two grouped together. Step 3, we ask, what do these two have in common? They're both divisible by 2 and x. So I put a 2x out in front, and if we divide both terms, divide each term by 2x, we write what's left over. We take a 2x out of this one, we're left with an x, and then 6x divided by the 2x is a plus 3. Close it off. Now we ask, what do these two have in common? Well, they don't really have any factors in common other than 1. They're both divisible by 1. But I do see that they both have a minus sign. So I'm going to pull out a minus 1. okay, minus 1 out of each of these two terms. And if I divide each of these two terms by a negative 1, I'm left with a positive x and a plus 3. Okay. All right, now let's see if we're on the right track. This should be the same as this, and they are x plus 3, x plus 3. And then this 3 is hanging out in front, not even doing anything with it at all. And since these two are the same, I'm allowed to pull that out to the front, x plus 3, and then write what's left over. Well, we have from this part, if we take that x plus 3, divide it out, we're left with a 2x. And from this second half, if we factor the x plus 3 out, we're left with this minus 1. And so this is fully factored now. We turned this original polynomial expression into something times something times something. That's factoring. Now let's move on to the next type of factoring on page 8. All right, this is what the other two types of factoring have really been leading up to. This is factoring a trinomial, and this is called the AC method. And a trinomial means that it has 3 terms. And so that is kind of, just want to point out the difference. Factor by grouping, this technique that we're using for factor by grouping applies to polynomials that have 4 terms. See, 1, 2, 3, 4, 1, 2, 3, 4. This technique that we're about to discuss is for factoring a trinomial, so it has factoring something with 3 terms. Specifically, this is going to factor trinomials in the form ax squared plus bx plus c, also known as the quadratic form. Okay, so this technique specifically works for trinomials in this exact form, where you have a variable, x is the variable, and a, b, and c are constant numbers. Okay, so this type of trinomial can be factored in the following way. Step 1, factor out the GCF if there is one. That's the same as step 1 on the last page. Step 2, multiply a and c together to get AC. Step 3, find 2 numbers which multiply to AC, and they need to sum, those 2 numbers also need to sum to B. Once you find those 2 numbers, step 4, you break up the middle term, meaning this term, this is the middle term, or this is what I'm referring to as the middle term. You break up the middle term, bx, using those 2 numbers that you found in step 3. Well, if you split this middle term up, well now, instead of having 3 whole terms, you'll have 4 terms, so then you factor that by grouping, using the last technique that we talked about. Alright, so let's see how this one works. So I'm going to use a little visual device over here to help me when I do this. So we want to factor these expressions. And so this is a trinomial, 3 terms, that's in this quadratic form. So let's first write down what a and b and c are. b equals c equals. Alright, so if you compare this expression to this, we want to identify these numbers a, b, and c, these coefficients. So I see that a is this number 4, b is the number 9, and c is the number -9. So I'm going to put AC up here and B down here. So AC is 4 times negative 9, which is negative 36. B is 9. All right. And then in these two spots over here, all right, so actually we just finished step 2. I guess I kind of jumped right into it, but we didn't actually have to do anything for step 1 because there was no GCF. So step 2, multiply AC together, we get negative 36. Now we're on step 3. Find two numbers that multiply to this number, AC, and they need to sum to this number, B, 9. So we have to think of two numbers that multiply to negative 36, and then they sum to 9. So always think about the multiplying to this number first. All right, so the two numbers that we're looking for in this case are 12 and negative 3. Because 12 times negative 3 multiplies to negative 36, and 12 plus negative 3, that sums to 9. So these are our numbers. Step 4, break up the middle term, which is this term here, by using these two numbers that we found. Okay, so the first term and the third term are going to stay the same. So I'm still going to just write 4x squared. But instead of plus 9x, I'm going to write plus 12x and minus 3x. So this 9x became 12x minus 3x. And then I have the minus 9 at the end. All right. Now we're on step 5. How many terms do we have going on? 1, 2, 3, 4. Well, when we have 4 terms, we want to try to factor by grouping. So let's do that. So these two terms, they both have a 4x in common. If we factor each of these first two terms, if we factor a 4x out of these two terms, we'll be left with x plus 3. And then if we factor, now we need to group these two terms together. What do these two terms have in common? I see they're both divisible by a negative 3. So I'm going to write minus 3. And if I divide both terms by negative 3, I'm left with a positive x plus a 3. And then these two turned out to be the same, so we're good. So we can pull that out to the front, x plus 3, and we're left with 4x minus 3. So that's using those 5 steps up here. Let's do another one. All right, so this part B, step 1, factor out any GCFs. Well, let's look at these 3 terms. Do these 3 terms have anything in common? They're all divisible by 2, and they all have a y. So I have 2y out in front, and if I divide each of these 3 terms by 2y, I get 6y squared minus 5y plus, well, 2y divided by 2y is 1. And this 2y is just going to hang out in front the entire rest of the problem. And then this is what we're going to be working on. So let's write down what A and B and C are. And we're only going to look here. So A is 6, B is negative 5, and C is 1. So just like up here, I guess I was using capital letters. Okay. I'm going to put AC here and B down here. So AC is 6 times 1, so that's 6. And then B is -5. So we need to think of, we're on step 3 now, we need to think of two numbers that multiply to +6, but they need to sum to -5. Alright, so that's going to be -2 and -3. These two numbers multiply to +6, and they sum to the number -5. So these are the ones we are looking for. And the point of these two numbers is that we're going to use them to break up this middle term. So we still have 6y squared, but instead of -5y, we're going to have -2y and -3y plus 1. And now we have 1, 2, 3, 4 terms. So we're going to factor by grouping. What do these two terms have in common? These two terms have a 2y in common, and if you divide each by 2y, you're left with 3y minus 1. These two terms don't really have a GCF besides 1. So we have to decide if we want a -1 or a +1. So I just try them out. I'm going to try out a -1. If I divide this by -1, I get a +3y. And if I divide a +1 by a -1, I get -1. And now I see, was that a good choice to put -1 here? Well, this is the same as this, so yeah, it was good. So I'm going to put my 2y there, and I have 3y minus 1 in common, so I can pull that out to the front, and we're left with a 2y minus 1. Okay. So that is our final answer. And let's just do one more like this. All right, so step 1, do we have a GCF? No. So next thing we'll do is write what A, B, and C are. A is 8. B is -10. And C is -5. So I'm going to put AC up here and B down here. A times C is 8 times -5, which is -40. And B is -10. So we have to think of two numbers that multiply to -40 and sum to -10. So sometimes it's helpful to draw a chart, a little T-chart. I need numbers that multiply to 40. So I'll start at the beginning. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And that's actually it. These are the only numbers that multiply to 40, and then we'd make one of them positive, one of them negative, so that it multiplies to -40. But if we look at all of these pairs, there's no way that any of these pairs will ever sum to -10, no matter which one we make negative. 40 and 1, that's not going to make 10. 20 and 2 isn't going to sum to 10. 4 and 10 can't. 5 and 8 can't. So there aren't any numbers that we can put here. So this particular trinomial is not factorable. Or sometimes we say that if something's not factorable, it's prime. Okay? Alright, so I just wanted to point out that that can also happen sometimes. So make sure you really have thought it very thoroughly, and if you're absolutely sure that you can't do it, then you can go ahead and write not factorable or write that it's prime.